Yo, what up? This is our group meeting. Woo! Oh yeah, got the way back.
I'll move my computer or my backpack.
Okay. Okay. So we divvied this up. Where is my part? Okay. So for number one, I got the period of the Earth, rotation in seconds. Let me pull up the question.
We have it right here.
Oh, yeah. Okay, so question one was, what is the period of rotation of the Earth in seconds? What is the angular velocity of the Earth? Given that Earth has a radius of 6.4 times 10 to the 6 meters at its equator, what is the linear velocity of the Earth's surface? So we know that the Earth, it takes 365 days. Yeah, for rotation. No. It takes 1 day. So it's 24 hours times 60 minutes times 60 seconds, which gives you 86,400. And then you have to divide that by 2 pi. So 2 pi divided by 86,400 equals 7.29 times 10 to the negative fifth. And then you go and you take the radius of the Earth, which is 6,371, and then you multiply that by your previous answer, 7.29 times 10 to the negative fifth, and you end up with 0.46445, or in kilometers per second, or 464.44 meters per second. And that's my answer for number one.
Oh, me. Okay, you're next. So I did 4 through 6, but for number 5, so it was what is the ideal speed to take a 100-meter radius curve banked at 20 degrees for the angle. So the equation is V equals the square root of R times G times tangent and the angle. So it's 100 meters times 9.8 meters per second squared times tangent 20, and that equals 18.9 meters per second, which is the ideal speed it would take. And then I had 7 through 9, right? And for number 7, we deliberated about it for a couple minutes, but we decided that Tom was more correct on number 7, and we just decided that because there's a lot that factors in with obviously the satellite and how it rotates and the acceleration and stuff, but that the space has a different gravity than Earth does, so that's why we said
that. And I think that's about it. The only other thing I can think of is for number 3. The question is defining centripetal force, and then it wasn't so much that, but can any combination of forces be a centripetal force? Through a little bit of Google help and going through our book, we were able to guess that any forces or combination of forces can result in centripetal force. And that is just about it. Had a good meeting, and see you next week.